All right, guys, Higgy here. With the next video, we're going to talk about conservation of energy. The formula that you're going to see that you haven't seen before is mechanical energy equals potential energy plus kinetic energy. Now, we've talked about potential energy and kinetic energy. We have those formulas. All right, but what I want you to see today is that in any system, when you look at any little segment of a system, what you're going to see is that the energy stays the same within that system. The amount of energy stays the same. It just changes forms. And in our consideration, we're going to talk about it changing from potential to kinetic primarily. Okay, so let's look at our little ball example that's sitting 10 meters high, has a height or a distance of 10 meters, and it has a mass of 10 kilograms. All right, so we know that if it's at that height, then it has a potential energy of, I can find its potential energy by taking its mass, multiplying it, its mass times its gravity, times the gravity, acceleration due to gravity, times the height. Well, to do that is pretty simple. I take 10, multiply it times, that's right, 9.8, times the height, which is another 10. And when I do that, I see that my number winds up being 980 joules of potential energy. All right? Well, at the top, that's how much potential energy it has, 980 joules. Well, we also know at the top that we can consider its kinetic energy, and the formula for that is 1/2 mv squared. But since it's not moving, it has zero velocity over here. The mass may be 10, but since it has no velocity, I can plug all that into the formula, but when I do, I realize multiplying by zero gives me 0 joules, which makes sense because it's at the top and it's sitting still and it's not moving. All right, so that pretty much simplifies that, but what this formula tells me is that the mechanical energy is equal to, the mechanical energy is equal to the total of those two put together. So the mechanical energy is equal to both of those. So really I have 980 plus 0 equals 980 joules of mechanical energy. It's just a way of thinking about the energy within the system. So the total energy, that's really what mechanical in our term, in our use of it, is really describing the total energy. So the mechanical energy, the total mechanical energy in this system is 980 joules. All right? So that's pretty interesting. So if I add up the potential and the kinetic, I'll always get that. Well, let's travel this ball. Let's get this ball down here to the bottom. All right, so now let's say that it's hit the bottom down here. And it hasn't quite hit the bottom. It's right as it hits the bottom, and it has 0 height. All right, so we're going to figure out the potential energy at the bottom. It has a mass of 10. We're going to use this formula here, right here, the potential energy formula. Gravity is still 9.8, but now its height is 0 because it has just hit the bottom. Right as it hits the bottom, it's still moving, but it's hit the bottom. You have to think about it like that. All right, so that tells me that since I'm multiplying by 0, it has 0 joules of potential energy. All right? Well, at this point, I know now, I can figure out what the kinetic energy is. It kind of makes sense to me, but I can figure out what the kinetic energy is if I plug this information back into this formula right here. All right, so let's do that for a minute. Let's take this potential energy and plug it in right here. Because I know the mechanical energy in this system is 980. All right, so let's go over here. EM equals EP plus EK. I know that EM is 980. The total energy in the system is 980 joules. Now I know the potential energy at the bottom is 0 because it doesn't have any height. So I can put 0 joules here. So that means that EK, the kinetic energy, has to be 980 joules so that both sides of the equation are equal, so that this thing balances out, because that falls out and 980 equals 980. That makes sense to me. All right, so I can find this EK down here then by saying, I can also find it another way. I know that the EK down here is then 980 joules by using the mechanical energy formula. But I can also find it another way. I can use this formula here. And if I do that, I'll see that if I use EK equals 1/2 mv squared, then I know the mass. I have 1/2 the mass, and the mass is 10, all right? But now I need a velocity, right? I need something in there to square to be able to find the EK. I know that it's 980, but I want to prove it by using this formula. Well, to do that, I'm going to go over to another, equation. So I'm going to create another little flip chart here, and let's transfer this over to 1/2 mv squared, all right? And I want to know, I know that my mass over here was 10, and this was 1/2, and I'm trying to find the EK, but I need this. This is what I was trying to solve for. All right, I just rewrote what I put right here. Okay, I just rewrote this piece on another little slide thing. Okay, so I need to find this velocity is what I'm looking for. Well, if I remember back, I have this formula that my second velocity the square of my second velocity is equal to the first velocity times 2AD. That was from some work that we did earlier in linear motion. Okay, so we've seen this formula before. Well, if I have my little ball up here at the top and I know that it's not moving, then its initial velocity is 0, right? So that falls out. So now I can find the velocity when it hit the ground here, the second velocity, because this is V1, this would be V2. And I can find that because I know gravity, I know how fast it's going to fall, and I know how high it is. And this thing was 10 meters high, right, from our other picture. All right, so I want to find the velocity that this thing hit the ground at. All right, well, I can do that because I know this is 9.8, and I know that this is 10. All right, and this right here is 2, and that's going to give me that. So when I'm going to erase this, and I'm going to leave that up there. I'm just going to go around it. And when I know that my V then is going to be the square root of this. 2 times 9.8 times 10. All right, so let's plug that in. Let's use this calculator right here. Oops, can't use that one. I don't know what I just did. Let's try that, didn't work. There we go. All right, so 2 times 9.8 times 10. Clear this. 2 times 9.8 equals that times 10 equals 196. All right? 19.6 times 10, and I need the square root of 196. So now I have that, and I just hit the square root button here, and I get 14. All right? So that should be my velocity, meters per second squared, 14. Did I do that right? 2 times that, 19. I'm just checking my math. Okay, so now I can take this velocity and plug it back into our formula. Let's just do it right here. Let's plug it right here, 14 right here. All right, so now I can find my potential energy, which should equal 980. Remember, we were looking for that earlier. So let's do that. 5 times 14 squared. 5 times 14 times 14 equals 980. All right, so there's my proof that if I plug all this in, it goes right back and proves this piece right here, that if I put 14 in right there, then that gives me 980 joules, and that tells me the same thing that the mechanical energy formula tells me. Now that's kind of in depth there, a little bit drawn out, but I wanted you to see that really mechanical energy, at any point, if you know the potential energy and the kinetic energy, you know the mechanical. And if I know the mechanical, I know the potential, I can find, if I know two of them, I can find the third one. It's how it always is in physics. So let's do something a little bit different right here. Let's look at this thing in the middle. And let's say that it's fallen 5 meters. All right, so with that being said, I'm going to erase this stuff. All right, and let's see if I can do this without messing too much up. And I'm going to leave that up there because that's the stuff at the top. All right, I'm going to leave that up there because that's figuring stuff at the top. All right, and I did the stuff at the bottom, but we're going to do it halfway down. Okay, so the potential, now it makes sense that if it has 980 joules of potential energy at the top, that halfway down it should have half of that, which is 490. Because if we come here, we see 980 divided by 2, then we have 490. So I'm going to make this kind of prediction that it's 490 joules of potential energy. All right, that's my guess. All right, now, so let's plug it in. EP equals mgh. Mass is 10, gravity is 9.8, and the height is 5. Well, when I plug all that into this thing, let's see. Clear this. 10 times 9.8 times 5 equals 490. Well, there you go. So the EP is equal to 490 joules. All right, now, with that being said, I can come back over here and take this 490 and plug it into my formula that says EP plus EK equals my mechanical energy. And I can find out now, I can find out the kinetic energy here. All right, I can find out how much of my potential energy as it was falling turned into kinetic energy, turned into moving energy. And easy to see because what is my total mechanical energy in this system? That's right, 980 joules. I know the potential energy at this point right here is 490. So with that, I can find EK. And when I do the math and I take and subtract 490 from 980, I see I get another 490, which is my kinetic energy. And that makes sense. So that means half of my potential energy has turned into kinetic energy. All right, and I've just used the mechanical energy formula to find that. And I could also find the velocity that it was moving at this rate. And I'm going to do that on another page, okay? I could find the velocity that it was moving by the time it got here, and then I will see. So let's go to another page. So we have, it's fallen 5 meters, right? Okay, so let's clear this board and watch this. So I have my ball. It's fallen 5 meters. This entire thing is 10 meters tall. The ball is 10 kilograms. All right, so let's find the kinetic energy right here. Kinetic energy is 1/2 mv squared. Now I know I've done found it. I know it's 490 joules, but I want to prove that it's 490 joules by finding the kinetic energy using the kinetic energy formula instead of using the mechanical energy formula. So now I have the kinetic energy is equal to half. So I know the mass, this 1/2, I know the mass is 10, but I don't know the velocity right here, okay? So I want to find the number that fits there that I need to square. Well, to do that, once again, I use velocity squared. My second velocity equals my first velocity squared plus 2AD. All right, we know that since it's not falling yet up here at the top, the first velocity is 0, so that falls out. Now I need to know I'm going to multiply 2 times 9.8, and I need to know the distance. This is the key. The distance that it has fallen. Not the distance, the height that is, but how far has it fallen. Because this is kinetic energy, this is moving energy. How far has it moved? Well, it has moved 5 meters. Yeah, it's 5 meters from the ground, but it's fallen halfway, so it's fallen. We need to think that this is the area that we're talking about. This part right here, when I use the kinetic energy formula, I would be using this 5 up the top, not the bottom, and it matters. We'll see that in a minute. All right, so I'll put 5 in here, and when I do my math, then let's punch our math in. 2 times 9.8. I gotta have this times 5 equals 98. I need to square that. Square root of 98 is 9.895. Let me do that math again. I'm not sure I did it right. 2 times 9.8 equals that, times 5 equals 98. And I need the square root of that, which is 9.8. 9.8995. I'm going to put those numbers in. All right? Okay, so that is my velocity. And remember, I'm finding the velocity equals meters per second. All right? So then I'm going to take that velocity and plug it in right here, 9.8995. and then I just solve it. I'm going to find out what my EK is. It should be 490, right, if I'm not mistaken. All right, so let's put this in. 1/2, which is 0.5, times 10, times that squared, times 9.8995, times 9.8995 equals 490.02, whatever. And so, oops, excuse me, that should be 0.0. All right, so that's because of the rounding error. If you remember a minute ago, the velocity went on out. So because of rounding error, basically it's 490 joules. All right, sorry for the scribble scrabble. But the point is, you can find it either way. All right, so that's really that's kind of where we are. There's an example of this kind of a problem that we often see in terms of a roller coaster. All right, so you have this roller coaster that right here, here's your ground level, and right here, this hill is maybe let's see. Well, let's pick some numbers here. This right here is 60 meters. Let me clear that off. This is 60 meters high. You have a roller coaster that's like 200 kilograms. All right. Now, what you have to keep in mind that there is no friction on this thing. So that's the first key. We're dealing with a non-friction, and we're dealing in a non-friction environment right here. Okay. So let's just kind of look at this thing real quick. I'm going to kind of run through some quick situations, but let's find the EP and the EK here at 1 and at 2. All right, and this hill is 60 meters, and we're going to say this hill is 20 meters. All right, so let's see how to do that real quick, the quickest way to do that. All right, the quickest way to do that, EP is mgh, EK is 1/2 mv squared. All right, well, let's find, and I know that EM equals EP plus EK. All right, we're going to use that formula a lot. We're going to use that a lot. Okay, so let's find the potential energy up here, because I know first of all, the EK up here at 1, the EK is how much? It's not moving at the top, it's sitting still. All right, so it hasn't started moving yet, so its EK is 0 joules because the velocity is 0. But we need the EP, and we're going to find the EP by using mass, gravity, and height. Mass is 200, gravity is 9.8, and the height is 60. And so when I punch that in, I've already done the math. Here somewhere, the EP is 117,600 equals 117,600 joules, 117,600 joules. Okay, so with this information, I can solve this thing pretty quick. I've got 2 of the 3 for this formula. I know that the EP, is 117,600 joules. I know the kinetic energy is 0 joules, so therefore I know the EM equals 117,600 joules equals my EM, right? So now I know all 3 of those up there. Now, that's pretty cool. Let's go down here to this one. All right, so since I know this is 20 meters, let's find the EP and the EK here. EP equals mgh, EK equals 1/2 mv squared, and EM equals EK plus EP. And I've written all this down 300 times, but just write them. We're going to see how we use this. All right, so I know the mechanical energy in the system stays the same the whole time. This is the key piece of this, is that once I get this roller coaster moving, the mechanical energy is going to stay the same all the time, so that I'm not really going to deal with these formulas over here as much, because I've got this mechanical energy knowing that it's going to stay the same. And since I've already figured it at the top, it's going to be that the EM is going to be the same here. So the EM here is 117,600 joules. Now all I need to know is find the EK and the EP. Well, the easiest one to find, since I have a height, is EP, the potential energy. And so if I find the EP here, really all I'm doing is I have a mass of 200, gravity, this is EP formula, mass, gravity, height. I have a mass of 200, gravity is 9.8, and my height here is now 20. All right, so when I do that math, what I wind up with is 39,200 joules, equals 39,200 joules. All right, and that's real handy. All right, because now I know the potential energy right here when that thing gets to this place. Its potential energy still is, now it is, because it's 20 meters high, its potential energy is 39,000. So now I can come over here. I don't know the kinetic energy. I don't know how fast it's moving. So I'm going to put a question. I'm going to put EK still here. But my potential energy is 39,200. And so now all I have to do is the math to find the EK is subtract 39,200 from this. And when I do, and that way I'll get rid of that on that side. When I do that, I'll find out that my EK is 78,400 joules. All right. So now I know the EP here. I know here. Excuse me. Here it is. I know the EP at this point, and I know the EK at this point. And the reason I know these is because I know the EM stays the same through the whole system. All right, it always stays the same. That's a key connection. All right, so this is one of those another one of those physics problems where you can't lose if you believe, focus, and don't quit. You have to believe you can find the answer, and it's always there. All you got to do is know 2 of the 3 of anything. If you remember, all you got to do, here's a formula. If I'm using this one, I've got to know 3 of 4 to find the 4th one. If I'm using this formula, I've got to know 2 of 3 to find the formula. If I'm using my mechanical energy formula, I've got to know 2 of the 3. It doesn't matter. That helps you believe you can find it. You have to know you can find the answer. It's possible to do. And if you focus on the problem long enough and don't quit, you'll answer it. And that's what this is all about, is focusing on the problem, knowing where you are in the problem, and never quitting on it. All right, so that's where we are with this, and this is going to get a lot deeper. So you need to make sure you keep up with your work as we go through this this week, because it's going to get pretty intense. You're awesome.